All right, welcome back, guys. So we're just gonna continue where we left off from the previous video. We left. We stopped the last video on the student T distribution. We started by discussing how will we go through the process to constructing a confidence interval to estimate the mean, the population mean. And in that process, we realized, okay, well, we don't have what we need. So that was, we can't just assume that the population standard deviation is given all the time if we try and estimate the mean. So instead of that, we use the sample standard deviations. As a result of that, we came about a new distribution called the student T distribution. And the critical values now is no longer z alpha over 2, but it will be t alpha over 2. And I'll show you guys how to do that, find that critical value in the next example here. But if you have time, if you want to learn more about the student T distribution, there's a great video on YouTube. It is called "What is the T distribution? An extended guide." So you just search this on YouTube and it's popped up, and I highly recommend it. It's about 20 minutes. Again, I can certainly make another video of discuss more detail about T distribution, but I figure, I'll leave that part to you if you're interested in, where exactly T distribution. This note kind of discussed a little bit what is a T distribution, but doesn't really fully tell what exactly it is, rather than the history and just the name of it. So certainly give that a try if you have time and you want to do some more learning there. We're gonna go straight to example 2. So in this example, I'm gonna walk you guys through how to do the confidence interval estimate for population mean. So suppose in this example here, we have speeds miles per hour measured from southbound traffic on I-80 near Cupertino, California. This simple random sample was obtained at 3:30 p.m. on a weekday. The speed limit for this road is 65 miles per hour. So use the sample data to construct a 95% confidence interval for the mean speed. Okay. So here we have 3, 6, 9, 12. So 3, 6, 9, 12. So pretty small sample size of 12 random, speed was measured on I-280 near Cupertino, California. So usually in order for us to use the T distribution, we have to make sure that our sample was given or selected from, from a population that is already normal distribution. So usually we would need to assess the normality of this sample data first before we can use a T distribution. So normally we need to verify if the sample comes from a normal distribution to use the T distribution. Okay. However, in this this class, or what we're doing right now currently, is we know just assume that it is normal, and there was a section that says on the normality we skip. So we are gonna skip in this section as well. We're gonna assume that it's come from a normal distribution. You can verify it. There's techniques for us to verify, but we're not gonna go in detail in this lesson here. So we're gonna skip the assumptions. So we're gonna go straight and just gonna go through the math part. How do you use the sample data to construct a confidence interval? So part A here, we asked to compute the sample means and the sample standard deviations. Okay, so just like the previous example, in order for us to compute the sample means, we can add all this number up and divide by how many there are. And then in order for us to compute the sample standard deviation, we could use the formula, manually crank through all the numbers, get the answer. But again, we're not going to do that for the sake of the time here. So we use a calculator and enter the data. So under stats edit, I've already entered the data under L2 list. So you go ahead and do that on your own there. And then we're gonna calculate the mean and standard deviations. Remember, that's calc one variable stats, and our data is under list 2. So that's gonna give us the mean is 60.67 miles per hour. The standard deviation there is gonna be 4.07 miles per hour or 4.08, either one. So I'm gonna go back to my note here. So the mean is 60.67 miles per hour. standard deviation is 4.08. Okay, so that's the sample mean and sample standard deviations. So part B, we want to find the margin of error by first find the critical value T alpha over 2. So the margin of error now is not Z alpha over 2 no more, but it's T alpha over 2 because we're using small sample data and then we're using T distribution times the standard error, which is S over square root of n. So S over square root of n is this is usually referred to the standard error because, we are estimate the standard deviation of the population. So since we're using the sample standard deviation, so there's some sort of uncertainties, there's some sort of error. So therefore, it's how many standard error away from the actual value. So there's two things we have to find. Actually, just one thing. We just need to know what T alpha of 2 is. Alpha is given. That's come from the level of confidence. So alpha is always 1 minus the level of confidence, which is 0.95. So alpha is 0.05. Or significant level is 0.05. So therefore, alpha over 2 is 0.025. So now T alpha over 2 now become T of 0.025. And that's going to be equal to the calculator command is this. Invert T of 0.975 and then 11. Okay, so I'll explain what this is. So this is degrees of freedom. So n minus 1, so degrees of freedom. Okay, and then this is the area to the left. Kind of similar to what we did in the Z alpha 2, the previous video. To find the critical value T of 0.025, that means the area to the right is 2.5%. That means the area to the left of this T curve is 97.5%. And because the T distribution consists of small sample size, the sample means and sample standard deviation always depends on what is the sample size. So the degree freedom is kind of act in that sense as if you have n values, then n minus 1 of those values is freely generated or can be chosen, and then the last one is kind of dependent. So that's where the n minus 1 come from there. So if you punch it in your calculator, you get the answer for the critical value is 2.201. And I'll walk you guys through how to do this in using the long way and also the short way in a second. But anyway, so we got the critical value, okay, which is that. So now we can figure out what our margin of error is, which is 2.201 times S. We got that was 4.08 divided by the square of n. N is 12, and that's going to be what? Let's do that really quick there. So we got 2.201 times 4.08 divided by square root of 12. So that's going to give us 2.59. Okay, so that is the margin of error. Okay, and again, I'll at the end of this video, I'll show you guys how to do this T critical separately there. So now, once we get the margin of error, we can go ahead and do the 95% confidence interval, and that is x bar minus the margin of error, and then x bar plus the margin of error to get these endpoints. So x bar was 60.67. The margin of error is 2.59, and then now 60.67 plus 2.59, and let's see what that comes out to be. 67 minus 2.59. 58.08, and then 60.67 plus 2.59, 63.26. So that's our confidence interval. So remember what this means. This is saying that we are 95% confident that the true value, which is the mean speed of traffic on South 280 or I-280 near Cupertino is between 58 miles per hour to 63 miles per hour. So that's the interpretation. In the previous lesson, we discussed what exactly we mean by this here. So certainly refer to the previous video for that. So the part that kind of confusing and hard in this lesson is that when you get to the critical value, when you get to the margin of error, like what exactly is the degrees freedom, what exactly is the T alpha over 2. So this here certainly the one that sometimes we forget or have a hard time interpreting what that is. So to keep it simple, T alpha 2 is the critical value that we use now, but not for the Z distribution, but for the T distribution, because the T distribution is a family of distribution, depends on the sample size. Different sample size generate different X bar, different S. Therefore, we need to identify those distribution based on the degrees of freedom. So if you go up here, this picture kind of demonstrates that with different degree of freedom, different sample size, we have different T curves. So that's what it comes down to, is because we're not looking at one single distribution to use or take critical value or base or critical value on it. We're looking at, infinite many distribution depends on the sample size. So let me show you guys how to get the 2.201 using the T chart, not using the calculator. So if you remember, I give you guys a formula sheet for our class, and that includes the T distribution critical value, if that's next to the positive and negative Z score there. So we want to find what is the critical value, T.025, sample size is 12. So first we locate the degrees freedom, and the degree of freedom is n minus 1. So 12 minus 1 is 11. So first we locate 11. And then we're going to go over this right side here and just figure out which, is it this column, this, or which one is it? So the key is 0.025. So because the confidence interval is act as a, you have a left endpoint, the right endpoint. So the 0.025 was split from the alpha over 2. Okay, so if we get 2.5%, meaning that's from a half. I mean, half of it is 2.5%. For one to tell, we kind of look like this here. So this is 2.5, and then this is 2.5, and that's generate the the endpoint of our confidence interval there. So area 1 tail would be 0.025. Area 2 tail is 5%, which is alpha itself. So that's probably the step that sometimes confuses students how to determine from the chart there. So we go down, and that will be your critical value there. So that itself is the T of 0.025. Okay, so that's using the chart. Now suppose we don't want to do all that stuff because it's confusing. You just want to plug, a few commands, push a few commands on calculator to get the answer. So what you can do is you go to this calculator. Yours can be slightly different. What you want to do is you want to locate the distributions for stats. So that's going to be second distribution, second vars or second distribution. And you're going to go down to the invert norm. Invert T, because we are working backwards to locate the critical value given the area. So invert T, which is the command 4. So invert T, the first thing you want to plug in is the area to the left of alpha over 2. So that was 1 minus 0.025. So alpha is 5%, significant level is 5%. So half of that is 2.5%. So we're going to look at the area to the left of that, and that is equivalent to 1 minus the area to the right. The area to the right is 2.5%. So 1 minus 0.025. And then, type the degrees freedom following. That is sample size, which is 12 minus 1. Okay. And that will give us the critical value, 2.201. 0.001 rounded up to the three decimal places. Um, so